Hi Longhorns, this is Miss Clay. Today we are starting a new unit on surface area. So as I always say, make sure you dog ear or flag your notes so that you know we're starting a new unit. So you'll be ready for your next test material as it comes up. Okay, so we're going to discuss surface area of prisms and cylinders today. So let's first start off by talking about what is a prism. A prism is a 3D shape with non-curved sides. So the key part about this is it's non-curved. That means they have flat sides. Okay. We also have a pair of congruent, which means the same, parallel sides called bases. So let's look at our cube here. And this a cube is a prism. So let's identify some of the pieces of our prism. So it says we have two congruent parallel sides called bases. So the top of your prism is a base and the bottom of your prism is also your base. So what it's sitting on, okay? Around it, you have what's called faces. There are lateral faces. You can just say faces for short, faces. So this cube has 4 sides, so that means it has 4 faces around and it'll have 2 bases. You also have what's called a lateral edge of your prism. That might be a little hard to see. Let's do this red right here real quick. It's not going to be straight, but you all can see him. Okay, this right here, the edge of your cube, this is called your lateral edge. Okay. And one of the last things to mention when we talk about is altitude. We've heard this word before. We used it quite a bit. And it actually just means our height. It's the segment that joins the planes together. So that the segment that joins our base with our other base. And so it's also called the height. So I'll put that right there. You know, this is your height. Okay? There's several different types of prisms. First, let's start off by talking about a triangular prism. If we notice, the triangular prism has a triangle shape on the bottom. So it has 3 sides on the bottom for its base. And of course, the top is the same. If we notice though, the sides of our triangular prism are a rectangle. Okay, so how we name our prisms is based on the size or shape of our base of our prism. So in this case, we have a triangle at the bottom, so it is called a triangular prism. Okay, let's look at our pentagonal. So if we notice right here, it has 3 sides at the bottom. And you notice you can still see the rectangles on the sides, on the faces right here, but it is a pentagonal prism. Same thing for a hexagonal prism. You see it right down there. A cube is the same on all sides, right? And finally, we have a rectangular prism. So a rectangular prism indeed has a rectangle shape on the bottom. It also has it all the way on all the sides and faces as well. But remember, that's how we name our prisms. Okay, so let's get into our surface area formulas. Surface area is the sum of all the areas at each of our sides. So if we picture that we got a box right here and we want to wrap it, well, the amount of paper that we use to cover our box to make our pretty present right here is the surface area. Everyone loves presents, right? So it's just the area all the way around. So if you really wanted to make this like a cube, we could say it's the area of the paper wrapping around our cube. The formula is perimeter. We know what perimeter is. We've had it before. Perimeter is just adding the sides together of your shape times the height plus the area of the bases. So this will depend on what base structure you have at the bottom. So it determines which formula you use. We can write it for short. SA, we can use SA to stand for surface area, is equal to P, perimeter times height plus 2 times the base. And we got a little figure right here. So B stands for area of the base. Okay, height and our perimeter. All right, so let's do an example. Okay, So this asks us, what is the surface area of the prism on the right? Use a net. So a net is a way of kind of unfolding your prism to help you see it. The problem sometimes with especially 3D structures, we have a hard time visualizing it. So let's pretend we're gonna cut this guy right open right here, all the way around that. And I'm gonna do the same thing down here where my black line is. And then I'm gonna cut this open. So it's gonna kind of unfold on us. Okay, so I've got a cute picture right here to show us what it would look like unfolded. So this is a net. So if you see that on your homework assignment, it says use a net, that means to draw out the faces and your bases of your structure so you can calculate the area. So it said the surface area is the sum of all the areas of all the sides. So let's look, let's start off. We have 4 times 3 right here, because these are all rectangles. So remember, the area of a rectangle is just length times height, or what we were using before for some of our other programs, we were just saying base times height. But we'll just say 4 times 4 is equal to 12. And so, of course, this one down here is also equal to 12, right? It's the same. And now let's do our inside faces. We have 5 times 4 is 20. We have 5 times 3, 15. Let's do this one over here again. We got 5 times 4 is 20. And the same right here. Okay, so what it says it's the sum of all the bases together. So that means we just have to add them all up. Okay, so that would be 20 plus 20 plus 15 plus 15 plus 12 plus 12. Well, we put that in the calculator and we get 94. And do we remember our units from last time? We had centimeters, so it's going to be centimeters squared. Let's not forget our units. Okay, now remember we had this formula that I just showed us on a previous slide. Let's try our formula and see how we do for that. So it said P stands for the perimeter. Okay, so our perimeter is of our base is 3 plus 4 plus 3 plus 4. Okay, so this all equals to 14. So I'm going to put that down. And it said times the height. Our height was over here, which was 5. Okay, so I'm going to put 14 times 5 right here. Okay, the next part said 2 times the base. So we have 2 times the base was 3 times 4. 3 times 4. So that is 2 times 12. So if we do all that together, you can put in your calculator. You'll get 70 plus 24, which is equal to 94 centimeters squared. So you see that no matter which way you do it, you can use a little shortcut now with our formula, or if you forget, just take the area at each one of our faces and our bases, and you'll get the same answer. Okay. So the next thing we're going to talk about is lateral surface area. So how lateral surface area differs is this is the surface area of the object minus the area of the bases. So this time we're not including the bases. We're taking them off when we do our calculations. So here's our little formula. And we can say LA for short. Lateral surface area is the perimeter. So remember that's going to be P of the base times height. And we got our figure here to show us. Here's our formula. LA is equal to P times H. Okay, so here it asks us to find the lateral surface area of the prism. Okay, so our base is down here, but we don't need the base. Oh, but we do need the perimeter of the base. Okay, and we need our height. Our height is over here, it's 2.2. So let's figure out. So let's look at our figure from the top, because sometimes that helps us. So we have 4.8 on this side and 1.9 on that side. So all we're going to do is go 4.8 plus 4.8 plus 1.9 plus 1.9, and that's going to give us 13.4. Okay, and now the next step said to multiply by the heights. So 13.4 times 2.2 is 29.5, and this is going to be feet squared. Okay. All right. So now, if you hadn't noticed, we can make a relationship between the two. So we had surface area is equal to the perimeter times the height plus 2 times the base of the area. And we have the lateral surface area is equal to perimeter times the height. So we can substitute in lateral area for that equation, and we can rewrite it because it's pH, right? They're both pH. Surface area is equal to lateral area plus 2 of the base. Okay? So now let's solve a problem using it that way. All right, so let's look at this one. Find the surface area of the prism to the right. So let's look off the first. This is a triangular prism because we have a triangle at the bottom. Sorry, I kind of wrote over our right angle right down there. Okay, 6 is going to be our height. We got that. So we have 2 of the sides of our triangle, but we don't have the third side. Well, we notice this, of course, is a right angle right here. So first things first, we need to find our other side. So let's use Pythagorean's theorem to find the other side. So if we always remember, a squared plus b squared is equal to c squared. So let's see which one we don't know. Remember, I always draw an arrow across from a 90 degrees so we know where our hypotenuse is. So we don't know our hypotenuse this time. So we just do 3 squared plus 4 squared is equal to c squared. So that's going to be equal to 9 plus 16 is c squared. And that's going to be equal to 25, right? C squared is equal to 25. So c is equal to 5. Okay. And I'm going to put him right there so we know where he is. Okay. So now we know that. So the next step we needed to know was our perimeter. So to find LA, we need the perimeter. So let's find the perimeter of our base. So I'm going to just put perimeter right here is equal to 3 plus 4 plus 5. So 7 plus 5 is 12. Okay, so that's our perimeter. All right, next step in our lateral area equation is going to be to multiply by the height, and our height is 6. So we're going to get 72. So our lateral area is 72 feet squared. Now, our next part is 2 times the base of the triangle. Okay, so the base area of a triangle is 1/2 base times height. Okay, so in this particular case, our base is going to be 3 right here. Put label in 3. And our height is going to be 4. So it's going to be 1/2 3 times 4. So 3 times 4 is 12 divided by 2 is 6. Okay, so we have that. So now let's plug this into our equation. So we have 72 right here. And the formula says 2 times our base. So we'll have 72 plus 12, which is equal to 84 centimeters squared. Okay. All right, so now let's look at a cylinder. Let's find the total surface area of a cylinder. So remember we said a prism is a non-curved three-dimensional shape. So of course a cylinder is a curved three-dimensional shape. You have 2 congruent and parallel bases that are circles. So we use our rules for our formulas for calculating the area of a circle when we need to find our base. We have the same rules as far as our height is right here, and it actually forms a perpendicular segment that joins the planes. Notice we have a right angle right here in our little drawing right here. Okay? So let's look at our formula. So now we already established that there's a relationship between lateral area and surface area. So lateral area is the product of the circumference. Remember previously we said the perimeter, but what is the perimeter of a circle? The circumference, okay? So the product of the circumference and the height of a cylinder. So here's our formula. Lateral area is equal to 2 pi r times height, or we could say it's equal to pi times diameter times height. Okay, next equation. Total surface area. It's the sum of the lateral area and the areas of the two bases, just like last time, okay? So we can say lateral area plus 2 times b, or we can just plug in all the values from lateral area, 2 pi r times the height plus 2 pi r squared, okay? All right, so let's find the surface area of our cylinder. Okay, and I wrote our equations up here on the top just in case we need them. So let's see what this says. The radius of the base of a cylinder is 4 inches and its height is 6 inches. What is the lateral area of the surface area of the cylinder in terms of pi? Okay, so let's draw our radius. So it said our radius was 4 inches right here, 4 inches, and it said our height was 6 inches right here. Okay, that's the first part. So I did a net down here just to help us. So sometimes it might help us at first to get used to it. So this part right here is going to be 2 times pi r times h. Okay, well, if we look at that, let's plug in our values. I'll write it down here. So we have 2 times pi times r, which is 4 times 6. So 4 times 6 is 24, times 2 is 48. So that's going to be 48 pi. Okay, so let's write our equation over here. So we have 2 pi, and I'm going to write it the long way, so that way we actually, it might help us remember it a little easier. So I just solved this part, okay, which is 48 pi. So now I need to find the area of our bases. Well, we've been doing this, so we should be really good at it. So pi r squared is the area of our triangle, of our circle, I'm sorry. So pi, but now we're going to multiply by 2 of them, right? So it's going to be 2 times 4 squared. So that's 4 squared is 16. And 2 times 16 is 32. So the area of our two bases is this, is 32. So we can say 48 pi plus 32 pi. That's going to give us a total of 80 pi. Okay. All right, let's do one more. Okay. Find the area. This one, we're going to find the lateral area and the surface area of the cylinder in terms of pi. Okay, so let's look at this cylinder. I didn't make it draw a net for this one. I think if you need to, go ahead and draw it. Sometimes it helps. Let's see, our height is right here. This is 20, but this time it's given us the diameter versus the radius. But we can still use it to calculate this first part right here, right? Or if you're more comfortable, go on and figure out what your radius is. Just divide your diameter by 2, and so r is equal to 9. Okay, so let's say our lateral area formula is pi times diameter times height. So we're just going to plug it in. 18 times 20. So that's going to give us 360. Okay, and now for the last part, we have SA. So now we need to find the lateral area, which we have, plus the two bases. So let's find the base or the area of our circle. So you can use 2 times pi r squared, or you can use the diameter, whichever one you want, and we'll get 162 pi. So let me plug that in now. 360 plus 162 pi. Oops, I forgot to write my pi right here. Thank you, I forgot real quick. All right, so our total is 522 pi is equal to our surface area. Okay, I included a couple more formulas back here at the end, just like we drew, in case you needed to write them down again, in case you missed it. And you can always have it for your notes. Okay, that's all for today. Ask your teachers if you have any questions. Have a great day. Bye-bye.